Good morning, everyone. So we are here today in order to take an insight into the fraud detection problem, into the fraud detection techniques. But first, I introduce our data sponsor, Consel. Consel is a part of the Gruppo Sella. The activity of Consel are mainly related to consumer credit, but now we are focused on the e-commerce branch. So our team is composed by Alfredo Favenza, a researcher, Isabella David, a data scientist, by me, data scientist, at least wannabe data scientist, Roberto Catini, data scientist. Is the last one. Okay, this is a short sentences, but it's full of meanings because as online commerce becomes more common, fraud is an increasing important concern. I mean, e-commerce has changed our world in a sense. The customer's world, not all the world. So, fraud detection techniques is a hot topic today, and will become another topic in the future. So, okay, our goal is clearly improve the quality of fraud detection in two terms. I mean, we would like to classify the fraud and not fraud in the same time. This is a very great problem. The second point is decrease the need for human analysis of individual transaction because it's a cost, obviously, and we want to minimize it. The third point is a vertical point in the sense that defines a trade-off because we want to achieve optimal trade-off of total cost. Total cost is the opportunity loss plus operation cost plus fraud loss. Fraud loss is a cost because when you're suffering a fraud, you have to write on your balance sheet a loss, obviously. The operation costs are related to the activities on fraud detection, on handling, create documentation, stuff like that. And the opportunities loss is one of the most important because when your model says that a customer is a frauder, but it's not real, you lost an opportunity in terms of revenues. So this is a trade-off, and we would like to define the minimum of this total cost function. Okay, our data set is composed by 22,000 records, 46 features, and the 0.21 of the contracts are frauds. Okay, dataset contains different sources of information. The first is related to database loans, customer policies, and contains information about the loan amount, the number of installments, the address of the customer, telephone number, stuff like that. The Credit Bureau Fraud Alerts contains information, contains alert related to telephone number, ID. I mean, one of the most funny was, okay, the ID of the customer is released on Sunday, so this is very strange. The third one is the Credit Bureau Customer Loans, contains information about the financial position of the customer in terms of number of credit cards granted, number of credit cards extincted, and one of the most important feature is the rating provided by an external agency. Okay, finally a visualization of something. Okay, so now we can see that our data set is unbalanced. I mean, on the left side, you can see the frauds distributed across the country, and on the right side, you can see instead the loans distributed across the country. So there is no proportion, and so this is a classical problem in the classification of binary variables. So, okay, so other issues, other challenges. Okay, the problem is how can we select the relevant feature? Okay, in our data set, there are a lot of variables that are in a sense redundant. I mean, they report the same information and in other cases instead are correlated. So we have to select only the most important ones. And the most important problem is that when you are frauders, obviously you are trying to put fake information in a system. And it's very difficult to detect a pattern from a liar. So this is the problem. Another point is the lack of important features. I mean, we are convinced that in a model for fraud detection, IP and delivery address, transaction geolocation and timing, and the type of product has to be put inside our model. But unfortunately, we don't have this kind of variables. Okay, see, we have the IP address for a portion of our data set, but not for the total data set. Okay, finally, our algorithm is a weighted random forest. Weighted because of, as I said before, our data set is unbalanced, so we have to put more weights on frauds. So random forests are an ensemble learning method for binary classification, one of the best one. And the idea of the ensemble learning method is to define several base estimators, in a sense, and then take a sort of average measure of the probability. So the random forest is a set of decision tree, and any decision tree takes a subsample of the futures, and any decision tree returns a probability. So probability to be a frauder. Okay, obviously we have to define the most important futures. We used an automatic procedure. The most important ones are, for example, related to the loan amount, to the rating, and other important alert for the credit bureau system. So now, how can we evaluate the goodness of our model? Remember that we want to classify in a better way both the frauds and the frauds in the same time. So the best matrix is the ROCAUG. The ROCAUG goes from 0, and 0 means total misclassification, and 1 means total classification, so perfect classification. Our ROCAUG is it's very good. I mean, it's 0.87, so good result. Okay, now we take a part of our data set. We can call it validation test set, whatever. Okay, remember that weighting random forests return a classification linked to a probability threshold. So probability threshold, the threshold is crucial in the classification problem. And remember also that the threshold defines the trade-off between the opportunity loss and fraud loss. Okay, green box means correct classification, red ones means misclassification. So we have two thresholds. One is equal to 0.5 and the other is equal to 0.6. So the idea is that the algorithms, if the algorithm returns a probability is equal to 0.7, okay, you are a fraud, or otherwise you are not a fraud. Okay, so as we can see, our algorithm is able to correctly classify the 90% of not frauders, and the 10% of misclassification is a cost. In a sense, that is an opportunity cost, because in this way you are losing revenues. So this is the problem. We are able to correctly classify the 63% of the fraud. Then we compare this result with another threshold equal to 0.6. As we can see, we improved the amount of correct classification of the not fraud. But in the same time, unfortunately, obviously because this is a trade-off, our amount of correct classification of fraud is equal to 53%. So this is the trade-off, and this is a choice that has to be made by, I mean, no, okay. Okay, this is a screenshot of one of our data visualization tool. The idea is that on the x-axis you have the date, on the y-axis you have the probability associated to all customer. This is obviously a screenshot from a fixed period of time, not all of our records. The idea is to divide our plane, so in order to understand easily how many customers are classified as frauders. So this is the idea. So now I pass.
Let's switch to some fancy and visualization stuff. Okay, when we were thinking about how to visualize, I have to 10 minutes. Okay, I will try to be When we were thinking about how to visualize data, okay, it was not easy because, in our opinion, the domain is not too easy to visualize because, okay, finance domain as a domain when in general it's very hard to get information about the users, it's very hard to build, for example, a network, but it's an intrinsic nature of the domain. And so we had to think about how to do this, and we come up with some idea. Of course, when we succeed in having some geolocation information, that was not easy at the beginning, but okay, we succeeded on that, and the first thing was to visualize in a map. In this case, we used the Google Maps, the position of the frauds at the end. So in the red circles, you have where frauds happen in the country, and the one classified as frauds are red, and the one green are just a transaction that are not classified as frauds. So this was how we geolocalize based on postal code, right? Yeah. Then, okay, when we succeed in do that, we try to do the step ahead, and so try to visualize some heat maps. So this, okay, as Giorgio was saying, this is the distribution of the total loans. So how all the loans are distributed on the country. So you can see there are some cities where there are more transactions. Of course, the biggest city we have Naples, Milan, and so on. So this is not in this visualization. There is not the information about the frauds. This is the distribution, where the transactions are mostly distributed. In this visualization, we have the distribution of the frauds. So of course, they happen in more the same city, but it's a logical consequence on the fact that we have more transaction in the biggest city than in the other one. So, but okay, we use this information to infer some conclusions. And okay, then this is the first type of visualization we realized, and then we also try to build something like a dashboard for the manager, for the person who deal with data every day. Of course, as in every demo, we suffer some demo problems, but we will not notice because I will not mention. But after this presentation, we can show you the full demo. This is the trial. So basically, as Giorgio said, we have this scatter plot with the probabilities on the y-axis and the period we consider on the x-axis. So we have 2 years data, so we cannot visualize everything in one chart. So we decided to have a filter on date, which allows you to move on the month. So if you move, you see different distributions. The second filter is one of the advanced version I will show you after this demo. And there is another feature. Okay, we can see here just the distribution of the frauds and what we classified as frauds and non-frauds. If you click on the loan amount, you have one more dimension. So you can see, for example, that it's not true that frauds on larger amounts. It's not a clear consequence. Sometimes it happens, but it's not. There's not a correlation between frauds and the loan amounts. And another, okay, the same chart has been made also in order to show how our model work. This chart represent in green the frauds, the non-frauds, and red the frauds. So you can see at the moment how the model is working, even if probably is working well because we didn't have time to steal the new data produced by the machine learning algorithm. So this is using 1 or 2 days old results. We have better results at the moment, and we can show you. So here you can see, for example, in the month of August, we classified very well some frauds. Of course, the number of non-frauds that are classified as false, as frauds, is quite limited. So we can say that the model is working quite well. And okay, move on the circle. You can also get some information about the date of the transaction, the amount, the city of residence of the person who is doing the transactions, and some information about age and marital status that can be can be also useful to classify who is more willing to do any frauds. And so that's all. You want to add something?
This information is quite important for the user. This is an application that you could use every day. Like when a new transaction comes and you have to decide if you will give the loan or not. This is a higher threshold, like it's 0.8. So a good thing to know is that you are the one who will choose the proper threshold based on your parameters. So this is just an example. It's quite high, 0.8. That's all. It's quite important to know that you will decide what are your parameters to choose the threshold.
You want to add something? So, okay, thank you all. Thank you all the teachers, because we stressed you a lot during these days with the problems and personal and working problem, everything. Thank you to Christian and Laura for supporting us, and thank you to all for joining this presentation. Any questions?
How much does it cost, the extended version? I mean, the commercial one?
Yes, we have to decide the fee for... no, seriously, we can show you... Okay, it's nothing more than that, but we have just the South region's visualization in this part. We have a beautiful filter that can filter on country area. So you can visualize just the north, northwest, northeast, center, and south. It doesn't work on the penguins and just on the windows, and I don't know why. But okay.